All right.
Perfect. So I actually don't, you asked me if I could see your screen. I actually don't see anything from your screen at this point.
Ah, okay. Do you see the, oh, wait. Yeah, I have to restart this now that, okay.
There we go.
So now you should see the funhouse view.
I was just going to say, kind of look like facing mirrors.
And now you should see the title slide for the session.
That's it. Yep.
Great. Okay. So I'm going to begin the session slowly. I noticed that. Let's see. I noticed that Sarah hasn't been able to join us, but Rob Wilton has been able to join us. Rob is our new management area director. Welcome, Rob.
Hello.
And just so everybody knows, it's going to be a bit of a challenge for me to track the chat as well as the participants and the okay, that's a hum. I don't expect us to have to do any hums today. All right, so let's start up slowly, but I'll do this little tutorial first here. I'm going to share all the slides today. I think that's probably the safest option. And so when you're speaking, please tell me to advance the slides. Then there's a microphone, basically 4 buttons right below your participant view here, and the first the button all the way to the right will give you audio access immediately for some reason. When we have a mic line going, then you can join the queue by pressing the microphone next to that. And that, of course, that's what we usually do for questions during talks. So without further ado, so this is the benchmarking methodology session. Sarah Banks is my co-chair. I'm Al Morton. If you'd like to join our mailing list, welcome. It's very early in the week, so I'll touch on Note Well here. We work as individuals and try to be nice to each other. And that's particularly true this week because the chairs are all using a brand new version of MeTecho. And we're trying to run the sessions as best we can. There have already been some surprises this morning and about 10 or 12 messages to the working group chairs list that were very useful. So then basically everything that you activity that you partake in here at the IETF is considered a contribution. And as a result, those contributions are covered by IETF's IPR disclosure policy. We ask that you make your IPR disclosures early and often. We have lots of other policies which are listed in the BCPs here, anti-harassment and so forth, copyright. So by participating, please be aware of these. And if you need advice, talk to me or the area directors. Have questions, go for it on the on our mailing list or with the other materials that are available. Any questions? Okay, hearing none, I'll proceed. So then we've got our agenda today with status. We'll talk about all three of our working group drafts. We've got proposals on two of them. We've got a new proposal to upgrade the benchmarking methodology for network interconnect devices. And there were some questions on multiple loss ratio draft. And some email discussion of the network service function density, but the rest of them were not updated in time. So I'm sort of considering that maybe just the top three proposals will be ones that we cover today, and the last two probably not very much. So any questions or bashes to the agenda? Hearing none, let's accept the agenda as written. And I will note that Tim Carlin is taking notes today. If anyone out there can help monitor the chat or the jabber, that would be appreciated. I'm not sure. We don't usually get any jabber traffic during Bmwg, so it's not a hard job. All right, and Sarah has joined us. Welcome, Sarah. And okay. Uh-oh. Sarah, can you be heard?
Can you hear me, Al?
Now I can, yes.
Hello. Good morning. Sorry, I'm having some kind of weird issue with Meet Echo.
Yeah, everybody is, so don't feel bad about that.
Good, I think.
And incidentally, you'll hear me pronounce it completely differently, Meet Echo.
Oh, gotcha. I just wanted to let Tim know, hey, thanks for taking notes. I really appreciate you. This is almost better than being in the room where we have to beg, borrow, and steal. We had you signed up in advance, so thank you. And I'll give a hand on the Etherpad as well to cover you when you're presenting.
Very good. Okay, so let's proceed on to the working group status. The EVPN draft is back to the working group. That's Warren's decision. We've had some review of that on the list. And of course, the new proposals keep coming. We've got a long list here. We've got to develop some, some momentum behind a few and decide which ones the working group wants to take up at this point. Also, it behooves us to take a look at the ones that are not garnering any strength, and we'll just take them off the proposal list. Over the weekend, I updated the milestones, and you'll see that we've got 3 here for August. Basically, the next-gen firewall, back-to-back frame, and EVPN benchmarking. I think these are actually all achievable in August, at least to get them to AD review. So that means having working group last calls and things of that nature. So and we've got promised updated drafts for 2 of them, and I probably in general there'll be if there's any comments today, updated drafts for all of them. And then we go out to December to pick up the additional items. Any questions about that? Okay, hearing none, that's it for the chair review. Very good. Okay. So I've got a quick status on the EVPN draft. The author is unable to join us today. He did not register for IETF, and I'm not sure what the barrier was. He's registered for and attended most other IETFs, but this time around he's not here. So the bottom line is I reviewed after we were asked as a working group to do some more editing for clarity in this draft. I did a couple of sections. I asked for more volunteers. I provided the author with some tools to help with his grammar checking and so forth. And the author, Sudin Jacob, he says he's going to work on that. And hopefully we'll see an updated draft soon. Any questions on that one? Still looking for volunteers to help with editing some of the sections there. Anything after section 2 needs help.
Totally. Can I chime in now?
Yes, go ahead, Sarah.
So for folks that are newer to Bmwg, this draft in particular is super approachable. Even if you come at it without EVPN expertise, just the flow of the document and the way test cases are written, and then of course some of the basic editing, right? This is a draft, I think, where just having a bit of that extra editorial help would be helpful. But in particular, this draft has gone through a decent amount of technical review, but the editorial part is what could use some help here. So just vanilla, how you approach test cases, along with just some basic formatting things. The tool I think that they were originally using is doing some funky things. And this is one of the documents that we've earmarked for August 2020 in the milestones that Al just put up. And so I think one way we could really get there and help pay it forward is to put a couple of extra eyeballs and hands on this draft. And you'll hear Al say, or you'll hear myself say often, like the easiest way to get people to review your draft is to review theirs. And so if you could help out in particular with this draft, I think Bmwg and the draft itself would be in much better shape. And we'd be super thankful for that. So please, if there's one draft you were considering taking a look at, don't be worried about the tech part. This would be the one for you.
Great, thanks, Sarah. Okay, so Tim, I'm going to bring you out of the queue.
Hi, I just actually had a quick question on the previous point for EVPN. I wasn't sure if there was a preferred platform. I haven't taken a really deep dive into the draft. I can possibly take a look at editorial wise some of it. I know some groups are using a GitHub. I don't know if there's a preferred format for sending changes, if just a simple diff is okay. What does the group tend to like as far as sending back those kind of small edits?
Yeah, we're not using a GitHub for anything at the moment, and we've been relying on communications via the email list, and they're pretty much any commenting format will help. The
Okay.
old new format or like a text file where you've done some corrections and then do a diff and then send the author the text file too. However it works for you is fine for us, and I'm sure fine for the author as well.
Sure thing.
And just a small point specifically on this draft, Timothy, if you find yourself wanting to make a bunch of changes, everything Al just said is perfectly correct, and that is exactly how we do business. However, with this author, generally, I find Sudin, if you find yourself wanting to make a lot of changes, like I did it initially, I actually just pinged him and said, hey, would you share the document? And he's generally okay with me making edits in line, and it's text, it's very approachable, and he's very good at doing the diff on his own. So it's another way if you find, for me, sometimes I find it tedious to say in section 1.3, please consider changing the sentence blah to blah. Sometimes it's easier just to make the change. And he's really good at just doing a diff to see what the changes were. So that's another option, particularly for this draft that might help you.
Great. Okay. Thank you for that.
Thank you.
Okay. All right. So next on the agenda is the next generation firewall benchmarking, Tim, and that's you. So let me find the right talk here. I think it's this one. Yep. Okay. and you're in. Good.
There I am. All right. Thank you, Alan. Sorry. Yeah. So Tim Carlin from University of New Hampshire Interoperability Lab, speaking today about the NGFW draft. Reminder, this is the draft that sort of guides the NetSec Open certification program. So wearing sort of multiple hats as a participant and a lab and sort of a supporter of that program. So I'm not an author of this draft, however, so detailed questions about that I'll do my best to answer. But I think we do have some experts as well on the line here, so we'll all do our best to answer any questions, and I can give a high-level update of where we stand. So first, or next slide. So the current draft is 03. I know we are a little bit late on providing an update, so hopefully we'll be able to get that in pretty soon. There are links in the I used to call it Etherpad. I guess it's not Etherpad anymore, but CodeEMD to a couple of mailing list archive emails that we've put out there that I think got a little bit of traffic on. So we'll try to be resolving those at least for the next version of the draft. As far as additional updates, basically they revolve primarily around the addition of the network IPS section to it. Previously, it was focusing more on the performance benchmarks. So, I'll try not to read verbatim the slides. You can see here what things are getting updated. CVE tests the security effectiveness, and that's pretty much the running theme here. And then looking at those KPIs or key performance indicators. So blocked CVEs, bypassed or not blocked CVEs, or allowed CVEs. Background traffic, and basically seeing what happens to that during the testing, and then the statistics following that. So next slide. Other additions here for the security features, SSL inspection, anti-malware is a big one that we're working a lot through here. Anti-botnet, of course, logging, identification, inspection, evasion, and all related to the network IPS section. Not too much in the security features section regarding NGFW. Next slide. Sorry, next slide if you could.
Sorry, Tim, I had to get up for a minute.
No worries.
You got through that one really fast.
Yes, I did. Sorry. All right.
Okay.
So the next one, again, not too many changes as far as test equipment for NGFW, but for network IPS, there's a fair bit of changes coming here regarding the configuration. Talking about the distribution of HTTP, HTTPS, first off, the requirements that are already there are pretty much unchanged. They're remaining. Even distribution of HTTPS and TLS traffic over HTTPS. Got that backwards, but and we'll base those on the maximum throughput, or the results determined that we in previous sections of the test, and then also CVE traffic transmission rate. So trying to figure out the how many CVEs per second basically are able to be supported, and determining the those values to help configure the equipment. And then you see that this is kind of going to be done sequentially and multiple times to try to generate those measurements. And next slide. So here for the validation criteria, the number of failed transactions in the background traffic, we're specifying it should be less than 0.01% of attempted transactions. And then the number of terminated TCP connections, we specified the same value there for that. It should be less than the total initiated connections in the background. Of course, the different phases here. So during the sustain phase, the traffic should be forwarded at a constant rate, and there should be no false positives. So this is all text and changes that are coming. The best way to do this is for us to sort of submit this text and have folks take a look at it, which we'll be doing. So that hopefully some of this starts to clear up as we do that. And we can move to the next slide, I think, which brings us to the measurement itself and the KPIs. So basically it comes down to block CVEs, unblocked CVEs, the background traffic, and the statistics. So everything is a percentage. It's the number of blocked out of the total and the number of unblocked out of the total CVEs, and representing those as percentages. And then the background traffic is at a constant rate. There's no change based on the CVEs that are being tested. And then we'll have a, right, so we'll do one of the following. So it'll be no impact at a constant rate, either minor impact or heavily impacted. So basically adjusting the traffic to handle that. And then all of the statistics for each of these things. And of course, no changes here for NGFW for measurement. And the last slide. Again, just documenting these things around the test procedures and the expected results for background traffic and how to go about doing the CVE emulation. So that's it. That was the last slide. Again, we have a couple of, I think, technically open mailing list items, but I think they've been sort of at this point maybe agreed to as is. So if there's anyone who has any comments lingering on those specific things, please let us know. It'll be great. If there's any thoughts about how to handle any of these, always encourage more review or questions, and hopefully be on the lookout for text here, as Al mentioned, in the coming weeks. And of course, if there's any questions now, we'll be happy to take a stab at answering them.
One question, Tim, I guess, is about schedule for the planned updates. It seemed as you were going through here that the authors of the draft planned to add, and I was sort of scanning through, oh yeah, upcoming changes and updates. There's a whole list of things that they're working on, and probably some of these also are in the list as stuff that they're working on.
Yeah, I think the idea is to add, and we had some conversation about this, so maybe it's fair to bring this up again as to wanting to add the IPS information, which would be on for each of these topics and each of these sections to the draft. So the question we sort of had is, should we add it to this draft or possibly create a new one? And we seem to prefer and lean towards adding it to this draft, though maybe not for the August timeframe. I'm sort of speaking off the cuff here in terms of timing. Do you have any guidance here as far as how big of a piece to chew here, or if that's too much, or if the timing should be pushed out there slightly?
Yeah, I kind of think that, speaking as a participant, I would first wonder whether the IPS topics fit under the original scope that we adopted as a working group draft. And
okay.
I can say it's obviously it's kind of a gray area, right?
Sure.
And also, so then with my chairman's hat back on, we've already got a pretty large draft here. and that's going to mean a big load in terms of number of pages for people who are going to walk in and try to help this draft advance with their reviews. So, I mean, as speaking as working group chair, I would rather we bit this off in a couple of different chunks. But let me open the floor up here and ask how other people feel. I see Sarah has joined the queue.
Yeah, thanks, Al. On one hand, I think you could put it in this draft, but speaking as a participant, excuse me, but I do think the notion of a network IPS is on its own a huge feature, and whether or not every NG firewall actually supports that or supports the same breadth or depth of that, I think potentially gets a little messy. So I tend to, I think, agree with Al, specifically because I think the IPS notion itself is pretty large. Having a separate draft for that might be nice and make this a lot more readable because the current draft is pretty large and that is a pretty hefty feature, if that makes sense.
Okay, and Brian Monkman, one of the co-authors, has joined the queue. Go ahead, Brian.
Not too sure. Can you hear me now?
Yes, can hear you now.
Okay, great. Yep. So what if we were to split out into separate drafts the security effectiveness side of things? So we would have security effectiveness requirements for NGFW, and we would have security effectiveness requirements for network IPS, and then have this, that would serve the purpose of decreasing the size of the current draft a bit, and those are the areas that are less likely to change significantly, and then we can move forward with the security effectiveness stuff in the working group. Would that make sense?
I think that's a path forward that might be successful too. It's I mean, like I said, it's already a pretty big draft. So in some sense, how the authors feel most comfortable doing the split is what you should probably recommend to the working group.
So what I think we'll do then is, Tim and I will take this back to the group at NSEC Open that's working on it, including the authors, and discuss that with them. Okay,
so we'll leave the future split of topics to the author recommendation, and look forward to an 04 version. After we've discussed that recommendation on the list that implements that recommendation.
Yeah. Okay.
Because officially now this is a working group document, so you've it's good to make a recommendation and then get some working group agreement.
Right. No, and that's the intent. Sorry if I misspoke.
No, not at all. Just trying to emphasize that point.
Okay. Thank you.
Just as
any other comments?
We are super, or at least I am, speaking as a participant, really excited to see a network IPS have that coverage come in. So please, I'm looking forward to reading that and giving you feedback. Thank you.
Yeah, thank you, everyone. We appreciate the feedback, and as Brian said, we'll see if we can try to make as minimal changes as we can to this, and maybe even shrink down the draft, and see if maybe spinning off another one, a new draft, makes sense for IPS. So we'll come back with some options.
Very good. Thank you very much for presenting today, Tim.
Thank you.
Okay. More email from the working group chairs. All right. So so next up is Al Morton with his participants hat on. This is the third working group item on updating the back-to-back frame benchmark in RFC 2544. And this is my minimal title slide. So here's what's happened. And although I've shrunk it down to one slide, it's a lot. One of our active participants, Vratko Pollock, sent comments in late 2019. And then when we had our May interim meeting, Vratko had to remind me that I hadn't seen his comments or hadn't addressed them at least. And I apologize to Vratko again. This is it's the kind of thing that happens at the end of the year when a bunch of stuff comes in all together, and it was actually a fairly stressful time for me. So I was able to get his comments, and then actually Vratko sent more comments to the list after our interim meeting. So those are his May 2020 comments, and they resulted in this whole list of resolutions here, that the buffer size is expressed in time in the original test. We've defined the buffer time, the buffer filling rate, the average repeated tests is a topic we covered in more detail, and the revised time correction factor to calculate buffer time again. So we've had support for this expressed over the last 2 years, really. There was a call for support early 2019, and the support's popped up many times. And in fact, the reason for the reviews that we're getting from Maciek, Konstantinowicz, and Vratko recently are because they're actually using the draft and the techniques in the context of their benchmarking, and their feedback is it's some very important testing. So, and I'll add that this is one of the several updates to RFC 2544, which is our foundational benchmarking for network interconnect devices. And several of the previous ones are listed here, and actually several RFCs that updated talk about state-of-the-art latency, which we're making a buffer time measurement here. That's important in that topic as well. So I'm going to go into some detail here. This is the kind of comment that that we've been dealing with. Basically, the mistake I often make in writing a draft like this, and especially in the first version of the draft, is that when I cite a reference, and in this case, the reference was the testing and the slide deck that we presented at the Open Platform for NFV Summit in the result of the vSwitch performance project of OPNFV. We presented slides at the summit basically describing this measurement problem with the current RFC and the solution. And we did that all in about 3 slides, including the measurement results. And everybody that looked at it, nodded their heads and said, "Great," So, but in the context of updating the RFC 2544 procedure, which was very concise. In other words, it was actually less than a page. We've described what the problem is with the current measurement, and talked about how we found that problem, and basically what we're doing about it. And the comments all along the way have asked for just a little more text here to explain what happened, and so on and so forth. So that's one of the sections that was added here. Basically, that if we were just looking at, and I guess I should give a little bit of background here. We have a traffic generator, and this little text diagram kind of explains what happens. We have a traffic generator that generates a burst of back-to-back frames, and that goes through the ingress links to the device under test. and the frames are stored in a buffer. And what normally happens is that there's a frame header processing, and when that happens, the frames are removed from the buffer, and then they go out the egress to the receiver. And so the strategy is to keep increasing the number of frames that are sent in a burst back to back. The minimum interframe gap and preamble on Ethernet, and then on the receiver, look for the longest burst where there's zero loss. And from calculations based on that burst size, the original 2544 buffer time was calculated. And what we noticed right away is that that original calculation didn't account for the frames that were leaving the buffer, because the buffer is alive, because the DUT is alive. It's processing headers, it's removing headers from the buffer, and as a result, the buffer is not only filling, but it's also being bled off. And so there was an important factor about the header processing to include when seeking information on the exact buffer size. And of course, as I mentioned here, there are many buffers involved in the device under test, but this is the model that we're using. It's a sort of a one buffer model, and this has so far not failed us. So that's a quick background. And when we were looking at the referenced testing in the OPNFV vSwitch performance project, we noticed calculations that produced buffer sizes of 30 seconds for some of the frame size. And that was clearly wrong. It turned out that was the limit at which the test devices involved would send a burst of traffic, and then they would just stop and zero loss, and so they would report 30 seconds. So it was very important to use the buffer time in the analysis, because that told us when we were getting bogus results for certain frame sizes. And that's a key part of this new procedure, that when you have frame sizes, very large frame sizes, the large ones that we test, when you have those large frame sizes and they can pass through the device under test essentially without buffering, then that means the header processing is not a limitation, and the header processing rate, and you can't really measure the buffer size with those frame sizes. So we've added that information into the procedures now to restrict the testing to the cases where only the packet sizes where the header processing rate is challenged. Those are the only places where you can make this measurement. And so more clarifications here, just adding some more text about, it's apparent that the device under test's frame processing rate empties the buffer during a trial. That's one burst, and tends to increase the implied buffer size estimate because many frames have left the buffer when the burst of frames ends. So we've got a calculation now of a corrected buffer size estimate. And then some more clarifications here. We're assuming that the packet header processing function operates at the measured throughput, and that's the just making that aspect clear. It's Veratko said, yeah, this is fine, and note that it's the best approximation we have, and that's exactly right. So all of that's been added. So here we add the definition of buffer time as the frames occupying the buffer divided by the maximum theoretical frame rate on egress for the frame size under test. And Veratko came up with an additional helpful concept, which is the buffer filling rate. It's the difference between the maximum theoretical frame rate on ingress and the maximum throughput the header processing on egress. So to bring the picture back up, we've got our generator generating back-to-back frames. That's the maximum theoretical frame rate. And then the slower header processing rate at the maximum throughput means that this buffer is going to fill up over time. And if you know the size of the buffer, you can calculate that. And if you assume a buffer size, then you can check some of your calculations and so forth, which is exactly what we did. So then some more changes here. The original text in the original definition in RFC 2544, the longest burst of frames as determined, process and buffer without frame loss as determined from a series of trials. So that's what we're working with. And then we added this new section 5.3, which has to do with the test repetition. And so we're saying that the test should be repeated at least 50 times with the average of the recorded values being reported. That's from 2544, and so therefore it's an average burst length, and we've clarified that. And there was a small clarification on the corrected buffer time, and that's basically what we had included in the text was this correction factor. It's a little bit funky here to try to see exactly what happened, but we've got a full equation now for the corrected buffer time, which, as I said before, was the most important thing to measure and report. So based on Vratko's comments, and the two of us got together and did some sample calculations, and we've agreed that this is correct. So then the next steps are to, it's been very quiet though, other than Vratko's few comments. As the author, I'm going to suggest that we trigger any concluding reviews with a working group last call, and we've got a draft that we can work with for that. And so Sarah, with your chair's hat on, you can take it from here. Thank you.
Yeah, I thank you, Al. I totally agree. It's I realize as a participant, I've actually been terrible in the sense that I read it and I thought it was extremely well written and didn't have feedback other than, hey, Al, it was really well written. Thank you. So I should probably drop that on the list. But to Al's point, I agree. I think we are sort of at the end of this. It's well written. It's been reviewed. It's got feedback. I would like to have this draft go into a working group last call. Any objections to that? We'll put this on the list as well.
Any comments today?
So I guess I would ask, hey, I'll drop the note onto the list. Folks, please, especially as drafts go into working groups last call, it's really good to get a feedback, a quick read through. I think it's extremely well written, and again, it's another approachable draft by the working group. So please take a look, and I'll take the action to put that onto working group last call after this meeting.
That's great. Thanks, Sarah.
Thank you.
Okay. So we have a so that concludes our three. Let's see. No, it's not that one. It's this. So that concludes our three working group items. So we're just in summary, we're waiting for an update on the EVPN draft. We're waiting for some more discussion amongst the co-authors and possible division of responsibilities here between on the firewall draft, but again, another draft coming. And we've agreed to start a working group last call on the back-to-back frame benchmarking draft. Very good. Okay, so we've got the remainder of our time to discuss proposals today, and I've teed up the newest proposal for discussion, and Gabor Lentz will be giving us that presentation today. Gabor is not new to the working group. He worked with our friend Marius on the IPv6 transition and techniques benchmarking draft some years ago, and so he's come back to us now with a new proposal, and you'll see lots of you'll actually see lots of references to that here. So I hope you've all read it. And let's see. Gabor, if you can press the microphone button, I will advance the slides for you. Okay, you're in the queue. I'll take you out of the queue, and you're good to go. And we can't hear you yet.
Try again. Can you hear me
yes.
well?
Yes, now we can hear you fine, Gabor.
Okay, first time I just had to tick some checkbox, and now it works. Thank you. So I have made some very tiny updates to the slides, but if you can show us slides, it's good. But may I share my screen? I don't know which is better.
It's probably a little dangerous, but
okay, if it's dangerous,
why don't you give us the updates verbally, and then you can send me another deck, which I will update as a revision.
Okay, they were just typos, so it's those slides are okay for me.
Yeah,
so
don't worry about that. Yeah, please proceed. Thank you.
Can show the slides. It's okay for me. So thank you very much for the opportunity to present our draft. And we have listed on the second slide. We have listed 4 things which could update old RFC 2544. But instead of reading them, let us jump to the third slide and start talking about them. So in RFC 8219, which I'm a co-author, and it is fair to say that I'm just a co-author of in a little part about DNS6 for benchmarking. The rest is the work of Marius. So in that RFC, Marius has recommended several good things, and I think it was accepted and approved by the working group. So I think they are good things. And now I would like to mention some differences between RFC 2544 and the new RFC 8219. So compared to the old one, some new measurement procedures were defined. They are packet delay variation and inter-packet delay variation. But not only new measurement procedures were defined, but also different summarizing functions were used. So in RFC 2544, the summarizing function is the average, which is a good and inclusive summarizing function. However, in some cases, it might be an oversimplification if we just use a single number instead of a lot of different numbers. And in the past, when we used hardware packet forwarding devices, it was usually not a big deal. But currently, when we use some software devices, it can be even a more dangerous thing to use just one number. And a smaller difference is that median was used instead of average, and median is less sensitive to outliers, so it's a bit different than average. And the main difference, I think, is that Marius recommended to use the first and 99th percentiles. Of course, if we have less than 100 measurement results, it's the minimum and maximum. So I think they are very good to use them because it can be a good measure of the dispersion of the results, if they are consistent or they are scattered. So I think it's a good thing to use them. And also, higher statistical reliability was achieved by requiring at least 20 tests. And some other thing that in original RFC 2544, it was only a single timestamp used, and in the new RFC, at least 500 timestamps had to be used. So I think they are good. And if we could go to the next slide, I would recommend to use these new things and to backport them to general network interconnect device testing, because RFC 8219 is just about IP version 6 transition technologies. But in the same way, we can test routers and other things. So we can use these new things in the old context. So why not we update RFC 2544 to do so? And we have also a tester, which was written by me. It is a SIIT-perf, which was intended to be an SIIT tester. It complies with RFC 8219, but it can be configured just to test, to benchmark IP version 4, IP version 6 routers too. So this tool can be used to do these new tests, and I think it would be a good idea to use the new test in the old context. So it's just an idea, and I have 3 others. So we have 3 others. It is the improved throughput measurements. So as you know well, RFC 2544 used the classic throughput measurement procedure that we send a number of test frames at a constant rate, and we count the sent and received frames. And after finishing sending, we just for 2 more seconds continue on receiving. So if we would like to be a bit tricky, we can say that the die mode for the first frame is 62 seconds, and for the last one is 2 seconds if we do a 60-second long test. It is usually okay if we use hardware forwarding devices, but there may be a problem if we use some software solutions, because in case of software, there can be some large buffers and interrupts, and it may happen that some of the frames are selectively delayed. So we just made an experiment, which was a willfully tricky case, when we delayed only 1% of the test frames by 100 milliseconds. And of course, it is not noticeable by a classic RFC 2544 throughput test, but we experienced that this little trick decreased more than by 50% the HTTP throughput download. So I say that if these tricks can be done and the throughput test doesn't notice them, then maybe we should have a new or improved throughput test which can notice them. So can we go to the next slide? Thank you. So we recommend a solution, and we call an improved and advanced throughput measurement procedure, which checks the timeout time for every single test frame. And it can be done, so this SIIT-perf program can do it. So I think keeping the old good throughput test, we could define an additional, I don't know which word is good, improved or advanced or which name could be used, but a different throughput test, which is sensitive to delay. And I believe that it can be valuable. And there was a discussion on the mailing list. So there's a link there when I try to explain why it can be better. But of course, if it's really better or if it's useful, it can be done by experiments. So in real life, if it helps, if it gives better results, more useful results, more I don't know, usable results, then it is a good procedure. If not, then we should forget it. So it was the second recommendation. And if we go to the next slide, it will be our third recommendation. So in RFC 8219, several times, at least 4 times, it is said that at least 20 measurements should be done. So the test should be repeated 20 times. And on the one hand, it would be a good guideline for throughput tests to have a fixed number. So at least 10 times or 20 times, we should repeat the binary search. But on the other hand, it's dangerous to say so because binary search is costful in the time of in the meaning of execution time. So a fixed number is probably not a very good solution. So on the next slide, we recommend that there should be an adaptive algorithm that performs a few benchmarking tests, and maybe after 5 or 10, it just checks how smooth the results are. So if the results are consistent, we may stop before 20 repetitions. But if the results are scattered, we can go further and not 20, but maybe 50 or 100 repetitions are necessary to have statistically relevant results. So it is our third recommendation. And we have a fourth one. Maybe some of you will not like it. Maybe some of you will. I'm not sure, but there's a fourth one on the next slide. And it is an optional non-zero frame loss acceptance criterion for the throughput measurement procedure. And of course, there are a lot of arguments for and against it. We have listed some arguments for it. So packet forwarding is often implemented nowadays in software. Unlike it was 20 years ago when routers were more or less hardware, today there are a lot of software things, and it's not feasible to require absolutely zero frame loss. And our applications got used to having frame loss, and this tolerates some low frame loss rate, for example, 0.01%. And some commercial testers, like Sparent, they have a parameter called sometimes loss tolerance, which professionals use and set to non-zero values many times. And if the practice is so, then I think it would be much better to recognize it as an optional test, and also to define a required reporting format where it is mandatory to state the loss tolerant list used. So it's much better thing to allow it and to make it mandatory to reflect what loss rate was used. So this is our ideas. And on the last slide, we just say thanks for listening us, and we are really eager to hear your comments, your ideas, and our question is if you find any of them useful. So they were just 4 ideas, and if you would like to, you want us to continue on this research, we are happy to just find a few of them, maybe 1 or 2, and continue on those things and just forget the others, or maybe forget all of them if you don't find them useful. So we are eager to hear your comments and reactions. Thank you.
Thank you, Gabor. I'd like to open the mic lines up to anyone with questions. Okay. All right. Well, I'll get things started a bit here, Gabor. I mean, this is the I guess this is the most controversial one here, the optional non-zero frame loss acceptance criterion. One way that we've been able to do this is to not disturb the throughput benchmark, but to add consideration for metrics like sort of phrased as follows: capacity at capacity at X% loss, and
sorry,
and that way we.
Sorry, didn't hear capacity.
Oh yes, capacity measured at X% loss.
Uh-huh.
So it's something that is included in the related metric, but it's but the true benchmark of throughput stands the same way it's stood basically since it was first defined in the mid-90s.
Maybe it's better to call it with a different name. Yes.
Right. And some other folks in other drafts here have tried to use other names as well. That kind of answers one of the questions on the multiple packet loss ratio draft, which we now probably don't need to cover. They were calling this this capacity measured at X% loss. They were calling that partial loss ratio measurements, and then they have so PLR, and then they have another level that they measure called NDR, no drop ratio, and so there's other schools of thought about the naming, but so far we've tried to maintain that throughput is the thing. Throughput is defined as it was early on for this group, and we'll try to maintain that definition, I think.
Can I ask a question now? To you?
Sure. Go ahead, Sarah.
Is your concern with that top bullet there, that top line, excuse me, is your concern around conformance testing?
Well, it's really a lot of concerns that we have this very solid definition, and a lot of people I've talked to, currently working in the industry, for example, Maciek Konstantinowicz, who does this testing all the time, and a co-author on the multiple loss ratio draft. He says I'm 100% with keeping throughput at 0 loss. I have no problem with that. Also, when if you remember our farewell. Our farewell meeting for Scott Bradner, one of the past co-chairs dug up an old email where the working group was starting to test at gigabit per second rates, and he asked on the mailing list, so is it time for us to allow a little bit of loss here? And Scott sent back a one-word answer. Scott's the founding chairman of the benchmarking methodology working group. Scott's answer was no.
I remember.
So I think with we're coming up on 30 years of history here with the definitions that we've got, and the truth is in measuring the virtualized environment, we noticed that some of the problem with measuring non-zero frame loss came from the fact that there were now transient interrupts in the device under test that were very difficult to set aside. And that had been our way of testing in the past had been of one where we tried to get all the transient activity and startup address learning, routing updates, all that sort of stuff. We tried to get that out of the way before we measured throughput. And when we're testing with general purpose computers or even high quality computers, they have interrupts that are fired all the time that need to happen to ensure the health of the system. And so what we created was a new form of binary search where we distinguish between steady state resource limitations and measurements which produce some losses due to transients. And we try to measure those two things separately. So that's a better solution than changing our loss threshold here, I think. And that's the one that lots of people have agreed with in the context of writing the ETSI NFV Network Function Virtualization Test Working Group's benchmarking standard. So I think that with a little more background, I think I shared you some of these links, right, Gabor?
Yes, I remember on the list. I read them.
Very good, very good. So at least we've talked about these things some, and I see our area director is in the queue. So Rob, you've got the floor.
So this is a comment as an individual, not as an AD, not wearing any hats. But basically, I think I sort of agree with what you're saying here, Al, that looking at that comment saying that packet forwarding is often implemented in software, where I sit, it actually is sort of the opposite. For all the platforms that I work on, you try and get nearly everything to go through hardware where possible. So I think there's very much separate classes of devices here in play, and you want to make sure that you don't optimize for general CPU-based ones against ones which are doing lots of hardware forwarding, where nearly everything is forwarded in hardware, and if stuff gets punted to software, then it's very, very strictly rate limited as to what you would do with that packet. So I think it makes sense to try and not change a base definition here, but just have more nuance in terms of how you do this. But I have to confess, I'm out of my depth in terms of this working group in terms of my knowledge and background. Hopefully
Well, but thanks for your comment, Rob. I appreciate it. It's you know, we're looking for more perspectives at this point, and I'm glad you inserted that here. Thank you.
So that first bullet under arguments was why I asked you the question, Al, because I don't know that I necessarily agree that it requires you to accept 0% frame loss, but I do think with experience on shipping products that do packet forwarding in software and on the CPU without the benefit of hardware, I do find that we're often asked for both. At what rate are you not dropping packets, which I think we are fine and we agree on. But then if I do quote unquote line rate, so if I'm taking in a 1 gig interface on the front end and you're not able to consistently keep up, you know, where do you land? So I have a bit of a soft spot for this, although I cannot argue against any of the points that you just raised, because I think they're all very good points too. So I kind of liked the fact that it was an optional one, but I guess to your point, Gabor, maybe if you consider positioning it, excuse me, along the lines that Al had mentioned for previous drafts, maybe you accomplish what you're looking for in a way that still holds true to Bmwg history. And not just to keep history, sorry, for history's sake, but I think those are prudent arguments that have served us well. And unless somebody's willing to stand up and say we should change it, and if that's the case, it's a conversation we should have as a working group, then I think amending these, as Al pointed out, is good. There's something about it is not feasible to require 0% frame loss that kind of sits a little funny with me. So I think that's an opinion as an attendee. Sorry, I'm not entirely sure that's super helpful.
No, I think your perspective is just as valid as anyone else's, of course, Sarah. I think Gabor is asking for a little flexibility here, and I simply described one of the ways in which we attack that problem. Separating out the metrics very clearly with different names. That seems to have made everybody who was a user of the Etsy testing spec happy. So let's look at some of the other ones too. I've got no issue with providing input on the statistically relevant number of tests. That's perfectly good information. I'd love to see more of that. In fact, I think we had a couple of presentations a few years back by his name escapes me now, but he was kind of adding his perspective on this topic as well. So it's kind of an action item to look back through our past agenda and to see if we can find some of his presentations. I can't remember who it was. He also gave some he also gave some kind of what do you call them, the sort of the bad attitude talks on Thursday nights. but he hasn't attended in about a year or so. So interesting guy from academia, actually. And then there's a couple of other questions here, which are related to the using the timeout for throughput. I don't think if you're actually able to measure the delays on every packet with your tool, then you could report the classic throughput, which has these delay criteria: 62 seconds for the first packet, 2 seconds for queue bleed off to collect the last packet, and then characterize the delay distribution at the throughput level of load. And once you do that, then you completely understand the delays and which are going to be in the 100 millisecond range and how often they occur in the distribution. And so basically replacing the now very weak, I'm just trying to find it here. Oh yeah, the very weak latency measurement procedure, which is in RFC 2544, with a much better one. That's obviously a great idea. And by the way, all the hardware generators do that today, but they instead of the 1% and 99th percentiles, I think they report min and max delay and the average. You're asking for the median here, so I'm fine with all of that, but I wouldn't trouble the throughput definition with it. I would treat these things as orthogonal benchmarks, where you've got a latency benchmark and then a more complete measurement of the distribution.
May I just have a question? So
of course.
In RFC 8219, many times appeared the number 20. How was this number selected? Why not 10? Why not 50? Why exactly 20? Why do you need just 20 tests, not 51 or I don't know? how this number was calculated?
Yeah. Do you? Well, I can answer that question with a silly question, Gabor. Do you still have Marius's email address?
Sorry, I didn't hear that.
Do you still have Marius's email address?
Yes.
So I would get in touch with him and ask him and let us all know what he says.
Well, I asked him and he couldn't say anything. He couldn't say a good reason why 20 was selected.
Oh, all right. Well,
he said that he didn't know of any considerations why exactly 20 was selected.
Right. Well, it's there are some rule of thumbs about a number of tests and so forth that have been floating around for years, but the truth is, as you said, you really have to look at the variation and from that decide whether you've got a consistent result or not, and that's hard to codify.
So when I did some tests, especially with DNS and DNS64 testing, it happens sometimes that in 10 measurements there were no outlier, but when I performed another additional 10, so in 20 there was one outlier. So maybe 20 is a good number, but I cannot say why.
Okay. Well, let's if we do update on this topic, let's try to say something about why here. I'm just quickly checking our time. So we can go to 50 minutes after this hour. Okay. All right, good. All right, so, oh, I closed the wrong thing here. Let's open it up again. All right. And of course, there's definitions for packet delay variation and inter-packet delay variation, which we've got in, I think, RFC 5481 is a good source for those. And the sort of the power and advantages of these two definitions are carefully compared in RFC 5481.
Okay, take the note. 5481.
Right. It's that one comes out of the IP Performance Metrics Working Group, where we make measurements on the production backbone network. And of course, those definitions are equally applicable here. It's a they each have their strengths and weaknesses, and this was this RFC 5481 is a applicability statement for the various forms that we looked at and did some analysis on. So what about your tool, the SIT perf tester? How fast on what's the biggest link in bits per second that you've tested using your tester?
So I tested 10 gigabit links, and with 84 bytes packets, not 64 but 84, because of the translation between IP version 4 and version 6. So with 84 bytes packets, it did 7 million packets per second instead of 14 million.
Okay. And you're using are you using UDP transport?
I use DPDK. Yeah, you use UDP, yes. I use UDP.
I'm sorry, I didn't hear your
response. Use DPDK, yes.
Yeah. You use UDP as a transport, right? Okay.
Yes.
How many flows, Gabor?
I just used a single flow, so just a single test frame was sent always. And I also did, because RFC 2544 is required to test with a single address pair and also with 256 network at different networks. So it can also do 1, 2, 4, 8, and up to 256 different networks. But I didn't use various ports, because I just used the test frame format from RFC 2544. And since then, we had a discussion with you about the change in the port numbers. So I'm to implement the change in the port numbers, but it's not yet implemented. So it was one flow or up to 256 flows. And if I increase the number of flows, the performance somewhat decreases if I do a self-test, but the performance increases if I do a routing test, because if I just use a single address pair, then just 2 CPU cores work on the router if I use a Linux router. But if I use multiple flows, even multiple networks, then multiple cores will working, so the performance increases.
Right. So, and a lot of people want to run the multiple flow tests anyway. So it's, it's good to know the single flow limits, but also then the multiple flow limits. And I guess you haven't tested this with 25 or 40 gig links.
So I plan to implement this multi-port test within a few months, and I will report if I added this feature to SIT perf. I will report on the benchmarking working group mailing list the new feature. In a few months, I will do it.
Very good. Okay.
So, what do you recommend with this draft? To keep the first 3 and abandon the 4th point, or just rename it to capacity measurement at X% loss, or others will do it?
That I guess that's where I ended up, but I encourage other folks to comment here as well with regard to the with regard to the way forward here. All right. So we'll try to get some more comments on the list, and as you said, Gabor, you've got a really short draft at the moment with where you obviously plan to do more development and so forth, and I think I think you've got some feedback today on where to put your emphasis for the next one.
So thank you very much.
Very good. Thanks for your proposal. Okay. So so then on the topic of the multiple loss ratio search, as I mentioned earlier, there was some questions from Sudin on the topic of, just checking to see who's here. I don't see Masiek or Vratko. Okay. So so without the authors, I'll simply mention that there are a few questions on the list for the multiple loss ratio search. This is where this proposes a search algorithm where you can measure, you basically reuse all of the your tests that you've conducted in the attempt to determine the throughput level that matches multiple loss ratios like 0, 1%, 5%, 10%, and so forth. So that I think, Gabor, that would be interesting reading for you. And then on the network function service density, Masiek, the author here, was asking that we sort of revisit the whole problem space and explore some tighter collaboration options. I exchanged some email with him on this topic, but I haven't received any response from anything recently from Masiek. So unfortunately, we can't move that one forward until we've got kind of like all the groups commenting here. But this is one where the OPNFV VS-Perf project is working as well. And Masiek was looking for kind of a cross standards development organization or cross industry meeting where we talked about this problem space. The main problem is that when you go to the container world and container networking, there's just so many options that we'd kind of like some help to pare things down. I think that's beginning to happen, but we want to try to accelerate it a little bit. So that's the short status of network service function density. And then no updates on the probabilistic packet loss ratio search. Vratko reported last time that it was still kind of experimental. The other EVPN drafts, we've asked Sudin to hold these while he gets some experience trying to get a draft, his current EVPN draft, through the IESG processing all the way, so he can fully appreciate what's involved there. And there's actually another EVPN draft lurking around. It's the one from me and my colleague Jim Utaro, which we haven't updated either. But we're hoping to get this first one out of the way before we see what faces us next. So, any questions on that quick status? All right. Well, I think I kind of think this was a meeting that was affected by vacations and the registration fee. At least we heard that from 2 people on the way in, and also we didn't get all the updates that we were hoping for either. So it's another reason that our meeting time was our agenda is a little light this time around. Let's put it that way. Is there any other business that folks would like to cover today? All right. Hearing none, I would particularly like to thank Tim Carlin for stepping up and performing our minutes note taker role today. Much appreciated, Tim.
Thank you, Tim.
Yep, very welcome. Thank you all. Appreciate it and happy to help.
Right. And thanks to everybody who joined. It was I think a pretty good turnout, and we will we'll expect to see you on the mailing list as we develop some of these working group items and our new proposals, which are all still very relevant. And thanks for joining us today, Rob.
No problem. Thanks for having me.
Yeah, Warren's gonna have to watch out. Rob did a good job.
Okay, everybody. We'll let you have a few extra minutes back in your busy week. So thanks again. Have a good day.
Thanks, folks. See you guys on the
Thank you.
list.
Take care.